I've never used captionings or captions, and I thought that the captions would show up, but I guess maybe they show up at the end. I have to learn new stuff every day. Oh, I should give myself a name. I'm in the jungle. How are you, Brandon?
Oh, good. How about you?
I'm doing pretty well myself, thank you. It's a lovely day today.
Hi.
So don't forget to say hi in the chat to say that you're here. Did you get on, Ariana? Were you able to get on My Math Lab, Ariana? All right, friends, don't forget to say hey in the chat so that I mark you as being present today. And then again, at the end of class, say goodbye, and I'll remind you. I hope if I remember. I just wanted to point out a couple changes to our homepage on Canvas, and they are here. If I can get that guy to move. I'm posting lecture notes, so I believe I emailed them to you yesterday, but if not, this is where they live. It's just a button on our homepage. It takes you to another page, which will have a table that's going to grow through the semester. For right now, I've got lecture notes for 7.4 and 7.5 on here. We'll definitely get through 7.4 today, and hopefully part of 7.5. But if not, we've got some buffer days in the next couple weeks that we can bleed into. But we'll definitely get any material that's due on homework, we'll get it done at least a day ahead of time. So that you have time to practice. And if you I don't think any of you have gotten there yet, but the diagnostic homework is 79 questions. So for the 6 of you who've gotten on my math lab so far, good job getting started. The rest of you need to make sure that you get on my math lab as soon as possible. 79 questions is no joke. Okay, there's a lot of material there. And you got to get through it. And it's, you know, some of the questions are pretty short and simple, and you're like, oh yeah, I can plot a point or something like that. But some of them take a little bit longer. You only need to get 70% of it done before you can move on to the homework that's due on Friday. Yeah, we'll have office hours tomorrow, same time as this class, 9:35 to 11. And I can help you with any questions on the diagnostic. I'm going to help you a little less than I would normally would, just because I want to make sure we're getting some real data. We really want to use the diagnostic to see where your knowledge gaps are, so that we can try to boost that knowledge base as we go along this semester. That's the X in the 96X. All right, any questions about the diagnostic homework due tomorrow at midnight? 11:59 to be specific. Okay, if anyone's having trouble getting on my math lab, please reach out as soon as possible. Also, like, don't let that be your stumbling block, because you really need to get started. Hit the ground running, as they say. All right, the other thing that's new on the, so you can see here, if you click on these 2 live links, that'll take you to the PDFs that we're going to use today. The other button that's new on home is Zoom recordings. This, oh, hi, Brandon. Hang on. Okay, yeah, I'll call on you. Go ahead. Brandon,
hello, good morning.
Hi.
No, I was just wondering, you said tomorrow at midnight. Is that so that's tonight at 12 o'clock, or is
no, so you have all day today and all day tomorrow up until 11:59 on Thursday.
Okay, perfect.
Thanks for clarifying, because yeah, midnight's weird. That's why we make it 11:59, so that it's confusing, but sounds like it still is. All right, so that's the lecture notes. Oh, also on the lecture notes, you'll see there's 2 columns. So this one is blank lecture notes, which is what we're going to start with today. At the end of today, when I'm done writing on my version of the lecture notes, I'll also post the updated PDF. So you can, you know, if you miss a class, or if I'm writing too quickly, or you just want to see my breakdown of a problem, which would probably be a little different than yours, you can come back here and look at those. Okay. Or if you lose your notes later, you can come look at mine. And then the other button that I added to the home is Zoom recordings. So all of our Zoom meetings will be recorded and posted here. I hope that doesn't cause any of you to be less likely to talk during class. We're a small group. No one's interested in looking at our classes, I promise. Unless one of you is like a superhero or like super famous, and I just don't know it, but you could just change your name on your thing, I suppose. Anyway, so those are here, same thing. It's just a link to a page, and then I'll the page will just have links here to those Zoom recordings, so you can always go back and look at class. And I've turned on captioning, but I guess we don't see it as it happens, but maybe I should be very careful to speak carefully so that the captions can be accurate. All right, any questions? Any technical questions going on? People having trouble with stuff or unsure about things or anything? Good. All right, shall we start with 7.4 then? Hopefully you all have at least looked at the PDF that we're going to work with here. Again, that table that I showed you is where you can find your version of it. A nice clean version of it. And then I'll show it to you right here. Yay, look at that. Okay, this is new technology for me, but I'm hoping it. Oh, good, look at us go. So I want to make this big. I guess that's as big as we get. All right, so 7.4 is our first 96 section. And we start out with adding and subtracting rational expressions with unlike denominators. So I just wanted to remind you that adding rational expressions is just like adding fractions. Okay, so let's just review that real quick. Remember how to add fractions with different denominators. So take a minute, each of you, and try these two problems. 2/3 plus 1/5. Okay, what? Oh, that's what that is. And then also, oh no. Okay, it's still here. Oh, good. And then also 7/10 minus 1/5. Just take a minute and try that on your own. All right, y'all ready? I guess I can just assume no feedback from anybody and I'll just talk like there's people here. Hi, Eddie. All right, so 2/3 plus 1/5. You got to understand that when I teach, I really try to get people to talk with me, and I tend to not go forward if I don't get any feedback. But I'm trying to get used to the fact that online people just sort of check out and watch it like it's a video. But please try to respect the fact that I'm a person and talk to me a little bit sometimes. All right, 2/3 plus 1/5. So what do we need in order to add those two fractions?
A common denominator.
Good, a common denominator. So what is a common denominator for 3 and 5? What's a number that will divide, that both 3 and 5 will divide evenly into?
15.
15 is a great one, yeah. Incidentally, it doesn't have to be the lowest common denominator. It just means less work for you if you can come up with the lowest common denominator. So in order to make 2/3 a fraction with 15 as a denominator, we're just going to multiply 2/3 by 5/5. Okay, and 1/5 is going to be multiplied by 3/3 in order to get it to have a 15 as the denominator. So now we just do these two multiplications and replace those fractions with equivalent fractions. So 5/5 times 2/3 is 10/15. There's that plus. And then 1/5 times 3/3 is 3/15. Now that they have a common denominator, we can just add the numerators. So I know this all seems fairly, like simple, like, yeah, we've done this a lot of times, but I just want you to consider these steps because we're going to do the exact same steps when we're adding rational expressions, when it gets more complicated. So notice that now what we get to do is just add the numerator, so 10 plus 3, and I'm going to write it all the way out. So 10 plus 3 is our new numerator, and the denominator, we don't do anything with those two 15s, it's just that they're both 15, so now we're allowed to add those numerators. And so we get what? 10 plus 3 is 13/15. Okie dokie. Let's do the same thing with the second one. And this one's a little different because our common denominator happens to be the denominator of one of those terms. In other words, that 10, this 10 here, already has a 5 in it as a factor. Okay, so we don't need to do anything to 7/10. So we'll just keep it as 7/10. But 1/5 needs to be changed. We need to write 1/5 as an equivalent fraction, that a fraction that has the same value, but that has 10 as the denominator. And we do that by multiplying 1/5 times 2/2. And again, multiplying by 2/2 is the same as multiplying by 1, right? Because 2/2 is just 1. And multiplying by 1 doesn't change the value of anything, all right? So 1/5 times 2/2 is There's that minus sign, 2/10. So now we have 7/10 minus 2/10. So we can subtract those numerators. We just have 7 minus 2 as our new numerator and 10 is our common denominator. And 7 minus 2 is 5. So we have 5/10. And here's a fun little extra thing that hopefully you all remember. I like this. I discovered this yesterday. It's so pretty. We get to simplify. Remember simplifying? All right, because there's a common factor in the numerator and denominator, namely that 5, we can divide out that 5 that's common in the numerator and denominator, and oops, and it's 1/2. Okay, excellent. So now that we've gone down memory lane, oh, that's fun. Look at that, it made itself a box. Not that one was too messy. Now that we've gone down memory lane and we remember how to hopefully add and subtract fractions, now we're going to do the exact same thing, but rational expressions are basically just fractions, but they've got some variables shoved in there somewhere. Okay, so for instance, check this one out. Remember, before we did 2/3 plus 1/5, now we're going to do 2 over x plus 1/5. It's basically the same thing. And so in order to add those two, you're going to do the exact same thing you did up here with this red one. Okay, in fact, let's use red again. So remember that the common denominator here was the product of 3 and 5, right? So now we're going to use the product of x and 5 as our common denominator here. So this guy, instead of being multiplied by 3 over 3, will be multiplied by x over x. Again, x over x is 1. Anything over itself is 1. And 2 over x gets multiplied by 5 over 5. Okay, so the first fraction becomes 10 over 5x. And the second fraction becomes x over 5x. Yeah? And now we can just add those numerators. Now, 10 plus x. I got people leaving right and left, coming and going. Okay, well, it's good to see those of you who are here. Don't forget to chat and say, hey, I'm here. And then again, when you leave, to say that you're gone. All right, can 10 plus x over 5x be simplified? Anybody? Does anyone want to take a stab at simplifying it? Okay, it cannot be simplified. Does anyone know why? Like, what is the rule? When do we get to simplify things? Like, why were we able to simplify 5/10 to 1/2? In other words, there was a 5 as a factor in 5 and a factor in 10. So we took that common factor and divided it out. Why can't we divide out, say, a 5 in this numerator and denominator, or an x in this numerator and denominator? Anyone want to be brave and tell us why not?
Is it because you're adding the 10 and the x on the top?
Good, that's exactly why. Because the 10 and the x are not factors of that numerator, right? They're terms that are being added, and factor means that it's being multiplied, and there's nothing up there being multiplied. Okay, so 10 plus x is the only factor that's in the numerator. Okay, cool. So it can't be simplified, so we're done with that guy. So we'll box him up. It didn't make a box for me. Maybe if I close it. No. Okay. How about the second one? The second one's very similar again to the second one up here, wherein we have 5x and 5 as our denominators. So 5 is a factor of both the numerator, or both of those two denominators. So the first one we don't have to do anything to. It's got everything in that denominator. It's got a 5 and an x. The second one has a 5. It doesn't have an x. It's missing an x. So that second fraction needs to be multiplied by x over x to bring it up to the robustness of the 5x in the first fraction. All right, so we've got the first one just gets rewritten, 8 over 5x. minus, there's that minus sign. And then 2/5 times x over x is just 2x over 5x. And now we can subtract those those numerators, 8 minus 2x, all over that common denominator of 5x. And again, 8 minus 2x does have a factor in it that we could take out. What is a factor that we can factor out of 8 minus 2x? I'll just tell you because it's kind of a weird question. You could take a 2 out of both the 8 and the 2x, and what you would be left with is 2 times 4 minus x. Yeah, and in the denominator, we still have a 5 times an x. So we have written that rational expression, that funky fraction, in factored form so that we can see all the factors in the numerator and we can see all the factors in the denominator. But there is no common factor in the numerator and denominator. If this 2 were a 5, then we could factor that out. But it's not, or if this 5 were 2 or something like that. No common factors, so we're done. Now, incidentally, this answer right here is just as correct. They're both correct answers, okay? It's just this one here is in factored form. So it sort of proves that it can't be simplified. Okay. All right, you guys ready to move on? I don't get you. Oh, you could also say stuff to me without saying anything, right? There's a button that says slow down, please, or a button that says go faster. So I believe it's under participants. You can click on that. And then you click on your name, or you can click on more. Yeah. All right. All right, I'm going to keep on going then. All right, so sometimes the factors are binomials, sometimes they're trinomials, and binomials are exactly what we have here, like with this 10 plus x, that's a binomial, okay? Or 8 minus 2x. Can you still hear him? Is it too loud? So in this first question in number 3, we have 2 over x plus 1 minus a fifth. And again, notice it's really similar to these other first ones. But now instead of just 2 over x, we have 2 over x plus 1. So x plus 1 is now the factor in that first fraction, and 5 is the factor in the second fraction. So we have to multiply those two to get a common denominator. Okay, so again, we're just going to multiply this first fraction by 5 over 5 so that we can bring in the 5 to the denominator in the first fraction. And on the second fraction, we have to multiply by x plus 1 over x plus 1. Because we need to include all the factors in both of those denominators in order to have a common denominator. All right, so this first guy right here, just multiplying it out, we get 5 times 2 or 10 over the denominator, which is 5 times x plus 1. There's our minus sign. And then this guy, yay, did it. 1 times x plus 1 is just x plus 1. And in the denominator, we have that 5 times x plus 1, which is exactly what we want. It is our common denominator. Okay. Good stuff so far. All right, and now all we're going to do is exactly what we've been doing. We have a common denominator so we can add or subtract the numerators. This time though, be careful because we're subtracting a binomial in the numerator. So I'm going to be super careful and use parentheses to include that binomial as a unit. If you just said 10 minus, for instance, let's put them over their common denominator, 5 times x plus 1. If you just said 10 minus x plus 1, that's not correct because we're subtracting the binomial x plus 1. Okay, so let's put parentheses around it so it's clear that we're subtracting that thing as a unit. Okay, and then what we've got is 10, and then it's minus x plus 1, which means, excuse me, we're subtracting the x and we're subtracting the 1. So it's 10 minus x minus 1. And then the denominator still, I'm going to keep writing the denominator in factored form so that we can prove that it can't be simplified at the end. And then we want to combine in like terms in that numerator. So the x can't combine with anything because there aren't any other x terms, but the 10 and the minus 1 can combine to 9. So we've got 10 minus 1 is 9. We still have a negative x, so 9 minus x all over 5 times the quantity x plus 1. And that's it. So it's written in factored form. 9 minus x is a binomial that doesn't have any factors that can come out of it. And then 5 is prime and x plus 1 is also a binomial that doesn't have any factors. So we could say it's a prime binomial. Oh, I thought that was a really good box. I thought it was going to make it a box for me. All right. How are we doing so far? ¿Hay preguntas? Any questions? No? All right. I'm going to give you guys some space, some time to yourselves to do this one right here, this 7 over 2 times x minus 1 plus 3 halves. I'll leave this on here. So please understand that you got to give it a try, even if it doesn't, even if it's really foggy for you, try and see how far you get. Make mistakes, because that will teach you where you don't understand, instead of it just being this jumble of, I don't get it. You got to try so you can figure out what it is you don't get. Okay, so give it a try. I'm going to include this one up here because it's similar to that as well. And if you do it real quick, then feel free to do the 2 on the bottom as well. All right. What are we going to do to these 2 fractions? What are we going to do to either one of them or both of them to make them have a common denominator? Would it make you feel better if I called on people? Ooh, slow down. Okay, see that. It did slow down. Just give you time. Okay. Let you go. Does anyone have any input? What can we do to either the first equation or first fraction or the second one to make them have the same denominator? What is the common denominator going to be? You guys, shall I put you in, how about this? Why don't I put you in breakout rooms so you guys can talk to each other, but you have to talk to each other, okay? I understand you don't want to talk to the big group. I'll put you in breakout rooms and you can work on these 3 other questions or 3 other exercises on question number 3, okay? So make sure you write them down. Take a minute to write all 3 of them down. You can take a picture of this with your phone if you want, or however you want to do it. And then I'll put you all in breakout rooms for, like, let's say 5 minutes, 10 minutes, and I'll come around and see how you guys are doing. Let's see if I remember how to do breakout rooms. It's been all summer. Not that way. Oh, it's okay. Break out. All right. Here you go. So it was the end. That's funny. Well, whoever you are, I'm going to put you in a breakout room that we're working on some questions. Put you in number 3. And go to room 3. And then I think I can close all rooms. All right. All right. So let's see what we've got. Some of you did them, others of you are stuck. So I'm just going to go through, medium pace and get those 3 done. And hopefully a little bit of it'll stick. And then we'll move on to some more complicated ones. And hopefully a little bit of that'll stick too. All right. So the first one, we have 2 fractions to consider. We have this denominator of 2 times x minus 1, and we have this denominator of 2. And we have to think about the factors in those denominators, okay? In 2 times x minus 1, we have 2 factors. In other words, 2 quantities being multiplied. That's what factor means. So we have the number 2, and we have the binomial x minus 1. Those are 2 different values, okay? They're being multiplied. And in the second fraction, all we have is a 2. It's not being multiplied by anything. So we need them to be the same. And the only tool we have is to multiply it by something, right? Because we're going to multiply by something over itself, or 1. So in this case, we can multiply that second fraction by x minus 1 over x minus 1. Okay, so now this is the fraction that we're changing so that it's going to have the same denominator as this guy. All right, so we'll just rewrite the first one, 7 over 2 times x minus 1. Okay, plus, there's the plus sign in the middle there. Now this next one, we're multiplying the denominator. The denominator is 2 times x minus 1, which is exactly what our common denominator is, which is great. That's what we wanted. But in order to multiply that 2 by x minus 1, we also have to multiply its numerator, 3 times x minus 1, so that we're not changing the value of that fraction. All right. And now all we have to do is combine, add the 2 numerators. All right, so I'll do this, bring this over here. So now we've got that common denominator of 2 times x minus 1. And in the numerator, we've got 7 plus 3 times x minus 1. Okay, and that's basically, we've done the addition now, but in order to sort of finish out the problem, we want to combine any like terms, simplify the numerator. It's sort of a mess. And then at the end, we want to see if we can simplify. Okay, but at this point, we've done the addition. The tricky part's done. So in order to see if we can combine any like terms, we'll have to distribute that 3 to both of these inside terms in the binomial. Okay, so we've got 7 plus 3 times x is 3x, and 3 times -1 is -3. And so you can see on our next step, we're going to be able to combine the 7 and the -3. All right, but the 3x doesn't have anybody to play with, no like terms, no other x terms. So the 7 and the -3 can combine to be 4. 7 and -3 add up to -4. I'm sorry, to +4. And then we've got our 3x. And then in the denominator, we have 2 times the quantity x minus 1. To see if we can simplify it, we look to see if there are any common factors. And again, the denominator has the factor 2, and it has the factor x minus 1. And in order to simplify, we would have to have a 2 as a factor in the numerator, which we do not, or an x minus 1 as a factor in the numerator, which we do not. That binomial 4 plus 3x, that's as factors as it can get. It cannot factor any further. It can't be simplified any further. So that's it. Now I feel like I'm saying way too many words because I'm trying to be very specific. Okay. Trying too hard. Chill out, Becky. All right, who wants to tell me what the common denominator is? Oh, you do get to see, what color should I choose? Magenta. Oh, green. Okay, how's that? Okay, what is the common denominator going to be in this 2 over x plus 2 and 6 over x? So think about it for a second. Think about what your answer would be in your head. And then I'm going to tell you what it is, okay? All right, so x plus 2 is a binomial. It doesn't have any factors you can take out of it. There's no way to factor x plus 2. So it's just a factor of itself. It's just x plus 2. And same with x, they can't be broken down into anything being multiplied. So just like way up here at the top, we had a 3 and a 5. They don't share any factors. We had to multiply the first guy, the 3 by the 5 and the 5 by the 3. We're going to do the exact same thing here, only now it's an x plus 2 and an x. In other words, this gets multiplied by x over x, and this guy gets multiplied by x plus 2 over x plus 2. And the reason for that is our common denominator is x times x plus 2. We have both of those factors represented now in the common denominator, okay? And the other guy is also x times x plus 2. Okay. It messes up our numerators a little bit, but that's fine because we need that common denominator in order to add. So think about what the numerator is for this first fraction. Think of it in your head, and then I'm going to do it. It's 2x. All right. And then the second one, think about what that is. I'll write it slow. Good job, 6 times x plus 2. Okay, now that they have common denominators, now we can add them up. So this one's going to be a bit of a mess, but I'll write it as a single fraction over the common denominator. That part I know I get to do. And then the messy part's the numerator. All right, so we've got 2x plus, and then I'll be careful to write it the way it is. Okay. And now, just like in the last one, we want to distribute that. Back in this one, we distributed the 3 so that we could see if we can combine any terms. Oh, here it is. Okay, so we're going to do that here as well. I'll rewrite the denominator just to be extra diligent. All right, so 2x plus, and now I'll distribute that 6 to both of those terms. We get 6x plus 12. All right, so now think about what terms I can combine in that numerator. Try to anticipate what I'm going to write next. Two x and 6x add together to make 8x plus 12. Now, that's a perfectly fine answer, but I want to be sure that this answer is in simplest form. And I know that numerator can be factored. In other words, there's something in both of those terms that's being multiplied by both of those terms that I can take out of the binomial. Think about what that could be. That's right, it's a 4. Good. All right, so if we take the 4 out, then we're left with 2x plus 3. And now everything's been factored, and I can see, so there's 2 factors in the numerator. One's 4, and the other one's 2x plus 3. And in the denominator, there's 2 factors. One's x, and the other one's x plus 2. And none of those are common, okay? If there was one that was in the numerator and the denominator both, we could divide them out, because something over itself is just 1. All right, but so this proves that it can't be further simplified. Okay, but the answer right above that, 8x plus 12 over x times x plus 2, is also a fine answer. But just to be safe, just to see if it can be simplified any further, it's a good idea to write it in factored form like that. All right, this one usually throws people because the second term that we're adding is 5. Doesn't look like a fraction, but remember, any whole number can be written as 5 over 1, as something over 1. So if that makes you feel, more like, oh, good, now I'm adding fractions, feel free to do that step. After a while, though, you'll just get more comfortable with it being a 5 and knowing that it's always a numerator. Okay, so we have 2 fractions here. One of the denominators is x plus 3, which is a binomial that can't be factored any further. In other words, a prime binomial. And then we have 1 as a factor as the other denominator. So we need to bring in any factors that are in one of the fractions that aren't in the other. And the only one that we have here is x plus 3. So this second fraction, 5 over 1, is going to get multiplied by x plus 3 over x plus 3, so that the 2 fractions have the same denominator. Namely, the first one gets to just stay what it is, 2 over x plus 3, and the second one is 5 times x plus 3 over 1 times x plus 3, which is just x plus 3. Okay, that was a little tricky just because of that whole number thing. Okay. All right, and now I think at this point, hopefully you all can see how when we have the same denominator, we just put it all over 1. We make it one big fraction, one big rational expression with that common denominator. And then we just add the numerators or subtract them. All right, so 2 plus 5 times the quantity x plus 3. Same step as before, we'll distribute that 5, we'll combine like terms, and then we'll see if we can simplify by factoring. All right, so 2 plus 5x plus 15 all over x plus 3. And now we can combine which 2 terms? I want to see.
The 2 and the 7.
Oh, there's no 7, but you're right.
The 2 and the 5 to make the 7. Sorry.
Oh,
Wait, can you do that or no?
no, but thank you for pointing that out. I hadn't even considered that. It does look like it, right? Because the 2 and the 5 are sitting right next to each other. But what you've got to get used to seeing is that this is not 2 plus 5, that the pluses and the minuses are what separate terms, okay? And so the terms we have here, I'm so glad you said that. The terms we have here are 2, 5x, and 15, all right? The pluses and minuses separate terms, okay? And so 2 is what we call a constant term. In other words, there's no variable next to it. It's just the number 2 that we've known for our whole lives. Same with 15, it's a constant term, there's no variable, okay? 5x though, it varies, it depends on what x is, right? So if x is the number 7, then 5x is 35, okay? 2 still 2, 15 still 15, but the x changes the 5x term, right? So he can't combine with 2 or with 15 because we don't know what x is, yeah? So we say that the like terms are terms that have the same version of x, the same number of x's being multiplied. So 2 and 15 are just like plain old 2 and 15 from way back. We can combine those. In other words, we can add 2 and 15, but 5x does not get to play with those constants, okay? Because he very.
Excuse me. Hi. What dictates if it's a plus or minus, negative or positive between the 2 and the 15?
Good.
Yeah.
Go ahead.
Yeah. How do you know basically? Why is it I mean, whether it be a negative or a positive?
Good. Well, luckily in this case, they're all positive, so we don't have to mess with that at all. But for sure, if say, if it were minus 15, then we would think of it as a negative 15. And we would have to add 2 and a negative 15, which is a whole different story. Okay. And we'll cross that bridge in a second. I'm sure we're going to find one in a second. Okay. But luckily right now we just got everything's positive. So we can combine that 2 and 15 and we get, oops, go back to orange, and we get 17. The 5x doesn't get to play with anybody because he doesn't have any like terms, so it's just plus 5x. And because everything's positive, we don't have any negative signs, okay? Now, 17 plus 5x doesn't have any common factor. There's nothing we can factor out of that binomial, so we say it's prime because 17 and 5 don't share anything, and there's only an x in one of them. So this is as simple as it gets. This is our answer to that last exercise. Okay. This is great. We are getting to some good stuff. I really appreciate you guys piping up and showing me what's inside your head so I can help. All right. So it gets a little trickier. Okay, before we're done, we're going to do these 4 trickier problems. All right. In the interest of time, I'm just going to do them and I'm going to talk through them, and hopefully you guys will pipe up when you're not sure. Okay, or if I've totally lost you, just pipe up to say, what the heck are you doing, Becky? We should have a safe word like pineapple or something that says, okay, I don't get it, stop. Okay. Pineapple. All right. Oh, check it out. The first one. What's so special about the first one?
The denominator is already the same.
Great. So we've already got that covered. All right. So we get to just write it. Orange again. As one big fraction with the common denominator as the denominator. All right. So take a minute, friends, and try to remember a little tip I gave you a couple questions ago, and then write that subtraction problem on the top of your numerator. Remember, you got to give it a try so that you know what you know and what you don't know. I'm not looking at it. It's just for you. All right, slowly. Ooh. All right, did I do it right? Sort of right. What do I need to include in there so that I can be, so that I'm subtracting that whole second binomial?
Parentheses.
Parentheses, good, good. That was the tip I said a couple minutes ago. So when you're subtracting a binomial, in other words, you're subtracting both these terms, okay? In other words, we want to subtract 4x and we want to subtract -21, okay? So that gets to your question, Brandon, from a minute ago about this, about the negative sign, all right? So we do have to remember our integer arithmetic, okay? And so subtracting a negative is the same as adding a positive. Two negatives. Okay. All right, and I'm happy to go over that with you tomorrow during office hours, because I love explaining integers, because I found all sorts of fun ways to do it. All right, anyway, so let's continue. We're now at that step where we're just combining like terms, distributing and combining like terms in our numerator, and then we'll look at the end to see if we can simplify, okay? So take your time, see if you can combine these terms without me. I'll take a minute and just do it slowly. All right, if that part's confusing, all I have to say is it's like distributing that negative sign, or we can say it's like distributing a -1 to both the 4x and the -21, okay? Subtracting the -21 is the same as adding a +21. Now we're going to combine like terms, and again, remember what the terms are here. We have 3 terms. We have a 7x, we have a -4x, and we have a +21, okay? So there's only one constant term, it's the 21, plain old number, okay? And then the other 2 terms are both x terms, okay? So you have 7x's and you have -4x's, all right? It's like 7 apples -4 apples, that's all it is. So because we're talking about, they're exactly the same x terms, okay? If there was like an x squared or an x cubed, they only combine with others that are like them. So x squareds combine with x squareds, x to the thirds combine with x to the thirds, etc. But these are both x, just plain old x's. So those 2 combine, and the 21 doesn't get to play with anyone. It has no friends in the whole, what's it called? Rational expression. Okay, so 7x -4x combined to +3x, just like 7 apples -4 apples, right? So 3 apples, and then +21 has to stay by himself. He hasn't got any friends. And then x + 7. Oh, that was fun. That's not what I wanted. And then we have, I don't know what made that happen, but let me get good at this at some point. X + 7 is our denominator. We want to make sure that we factored everything out of the numerator and denominator to make sure that there's nothing common. There's no common factors in the numerator and denominator. If there were, we would divide them out, and then we would it would help us to simplify. So I can factor the numerator because I can take a 3 out of both of those terms. In other words, I can rewrite 3x + 21 as 3 times x + 7. So again, if you were to distribute that 3 to that binomial, you'd get 3x + 21, right? So I just rewrote the numerator as the product of 3 and x + 7. Now what? And my denominator is x + 7. So the factors in the denominator are just x + 7 and 1, if you will. So here's a great example. We have a common binomial factor in the numerator and denominator. That x + 7 is being multiplied, excuse me, by a 3 in the numerator, and x + 7 is being multiplied just by 1, by nothing, in the denominator. So that x plus 7 divides out. In other words, it's a common factor in the numerator and denominator. Okay, and x plus 7 over x plus 7 is just the number 1, and 3 times 1 is just 3. Having really a lot of fun with these colors. So the answer in this case, which who would have thunk it? Look at that crazy where we started here. Oh, I'm getting really good at this. That equals 3, no matter what x is. X could be 0, x could be 105. If you plugged it in to this thing here, everywhere you see an x, if you plugged in 105, you'd still get the number 3. Or if you plugged in the number 1 for all the x's there, you'd still get the number 3. Because no matter what you do, that sum is equal to 3. There's only one value of x that you could plug into this and not get the number 3. Does anyone know what it is? It's the one that messes everything up. It's the only thing that's like a wrench in the cog of mathematics. I'm just going to tell you, if x were -7 in this particular problem, if you were to try to plug -7 in for x, you would have 0 in the denominator. And that is not allowed. No zeros in denominators. You can have zeros in numerators all you want, but no zeros in denominators, it messes everything up. It causes a hole in the space-time continuum, and nobody wants that. All right, new color. Purple, sure. Okay. All right, this one's a little tricky because in the second fraction, we have some sort of hidden factors in that denominator. So I'm going to start out by writing that second fraction over with its denominator written in factored form. Okay. Does anyone remember how to factor this binomial x squared minus 81? It's my favorite kind of factoring. Just so you know that personal thing about me. It's called the difference of two squares. And I'm going to do a little side thing over here, okay? If you have, say, x plus 2 times x minus 2, do y'all remember how to FOIL? FOIL? Look at all the foliage. Remember, first, outer, inner, last. Yeah, so we're going to have 4 terms when we multiply a binomial times a binomial. They each have 2, so they each have to partner up with the other 2. So x times x is x squared, x times -2 is minus 2x, x times positive 2 is plus 2x, and 2 times -2 is minus 4. Yeah. So the magic of this particular example is that these 2 middle terms add to 0. -2x and positive 2x add to 0. So they go away and we're left with x squared minus 4. That's why it's called the difference of two squareds. The x is the square of x. I'm sorry, x squared is the square of x, and 4 is the square of 2. Square just means you multiply it by itself. All right, so over here we have x squared, which is the square of x, and we have 81, which is the square of 9. All right, so we're going to write it in the same format as this. All right, so I'll rewrite it. The first guy, I'm just going to rewrite the way we see him. And then the second rational expression, the numerator will stay the same, but x squared minus 81, I'm going to write like this parallelogram over here. It's going to be, whereas here it was x plus 2, x minus 2, we're going to have x plus 9, x minus 9. I invite you to do the same thing I did over here, okay, with x plus 2, x minus 2, and then I FOILed it, whoops. and got x squared minus 4. If you do the exact same thing with x plus 9, x minus 9, hopefully, you'll get x squared minus 81. Okay, so same concept. Okay, all right. Now we can see in our, oh yeah, stroke eraser, this please. I'll take all this away. Good. Now we can see in our exercise that in our first fraction, 10 over x plus 9, we have a denominator of x plus 9. It's a prime binomial. It can't be factored. That's the only factor, x plus 9. In the second fraction, we have an x plus 9 factor and we have an x minus 9 factor, which means we need to incorporate the x minus 9 into the first fraction. And the way we do that is we multiply it by x minus 9 over itself. Okay, and in that way, this new fraction that we're writing will have the same denominator as this one. Okay. Back to magenta, please. There. I think that. No, there. Okay. All right, so let's rewrite the first one. We have a 10 and an x minus 9 in the numerator, so I'll write it this way. It's okay if you want to write it x minus 9 first and then the 10, but this is my pernicketyness. Remember, multiplication doesn't matter what order you write it in, it means the same thing. And then x minus 9 times x plus 9 minus, and I'll just rewrite the second guy, 9x over x plus 9, x minus 9. And again, doesn't, 5 times 7 is the same as 7 times 5, right? It doesn't matter what order you write multiplication in, it means the same thing. All right, so now we have the same denominator. All we need to do is subtract those numerators. So the common denominator is x minus 9, x plus 9, just those two factors in whatever order you write them. In the numerator, we've got 10 times the quantity x minus 9 minus 9x. And now we're at that point where we're going to distribute in the numerator and combine like terms and see if we can simplify. Okay. So think about what terms we can combine. That is just ugly and messy. Okay. While you're thinking, I'll clean this up. Okay. All right, what terms can we combine? We have 3 terms. We have a 10x, we have a minus 90, and we have a minus x. Oh, good. Brandon, we got lots of subtraction here for you. Okay. So what are our like terms?
10x and 9x.
Good. And we have a positive 10x and a negative 9x. So it's like 10 apples minus 9 apples, right? So it's 1 apple or just plain old x, 1x. All right. And then the minus 90 has to play by himself because he doesn't have any like terms. All right. That's as far as we can go because x minus 90 can't be factored any further. There's no common terms in the x and the 90 that we can pull out and write it as the factor of that number and the binomial. That's as far as we go. So we've written it in factored form. So we see there are no common factors in the numerator and denominator. It sure looks like there is because that looks like an x minus 9, but it's not. It's x minus 90. The number 90 is different, obviously, than the number 9. Okay. All right. We've got 12 minutes. So I'm just going to bust through these so that we have a full sheet of work done for you all. But again, feel free to holler What do you think? I want to go gold, but I'm not gonna. Okay. Red scares people, I've heard. Okay, let's go purple. For red. Okay. This one, there's another little trick here, and there is one of these on your homework. When you have a difference, in other words, a subtraction, like x squared minus 25, if you multiply that by -1, right, then the -1 gets distributed to the x squared and to the minus 25, and that would be negative x squared plus 25, which if you just switch the order of those, you'd have a plus 25 minus x squared, right? Which is exactly what this is. So the trick here is that if you have, let's see, x minus 3, let's make it super simple. If you multiply x minus 3 times -1, that's the same thing as 3 minus x. So multiplying a subtraction like that by -1 just switches the order of the subtraction. It's something that you just notice after doing it a million times, or someone like me comes along and just points it out to you, okay? So the reason to know that is for problems like this, and like I said, there is one on your homework. I like the x squared coming first, so I'm going to apply the -1 to the second fraction. And again, if I multiply the denominator by -1, then I have to multiply the numerator times -1, because in essence, we're just multiplying times something over itself, which is 1. So we're not changing the value of this fraction. Okay. All right. So I'm going to rewrite the first guy, 4 over x squared minus 5, and then minus, right? Because that's this minus sign. And then the numerator here is going to be a -8, because I'm multiplying times -1. The denominator, remember, since I'm multiplying this subtraction problem by -1, it just switches the order that you see them. So it's going to be x squared minus 25. Okay. And again, I'm happy to like really go into depth with this with you all tomorrow during office hours. And if you can't make it tomorrow and you really want to, just email me on Canvas and we'll set up another time. This is the only class I'm teaching. Got all the time in the world. All right. So now we're at a point where we can combine them over the common denominator, x squared minus 25. And it's 4 minus -8. And 4 minus a -8 is the same as 4 plus 8, or 12. 12 over x squared minus 25. And I'll just tell you, we could factor that denominator, and just to be consistent with everything else I've done today, excuse me, I'll factor the denominator. And that one's a difference of 2 squares as well. X squared is the square of x, and 25 is the square of 5. So that factors out to x plus 5, x minus 5. They're my favorite. And then the numerator is 12. You could write 12 as 2 times 2 times 4. No, 2 times 2 times 3, or 6 times 2, or 3 times 4, however you want to. You can factor it. But the reality is there's not a 2 or a 3 as a factor in the denominator. So it doesn't get, there's no way to simplify it. So we're done. Yeah. And you would have been done up here too. Either one of these answers is fine. All right. Last guy, 7 minutes. So for those of you who remember factoring trinomials, there are a couple problems in 7.4 where you need to remember how to factor the trinomials. So this guy's a trinomial, the denominator of the first rational expression. X squared minus 2x minus 35. And we're going to factor that trinomial into the product of 2 binomials. And it's on here just to see if you remember how to do it, I think. But they come up. Ooh, back to green. All right, so I'm going to start out by writing that first denominator in factored form so that we can see what the factors are of that first denominator, and we can see the factors of the second denominator so we can come up with a common denominator. And I'm just going to factor it in the interest of time, okay? But if you want to guess at what you think it is, or if you just are really good at factoring still, feel free to do that one on your paper. I believe it's x minus 7 and x plus 5. So yeah, because they shucks, let me do that right. Because they multiply to -35 and they add to -2. All right. Again, happy to review that with you all tomorrow or any other day. I'll just rewrite the second fraction. I always forget the other word for fraction. Rational expression. Okay. So now we can see the factors in the first denominator are x minus 7 and x plus 5. The factors in the second denominator is x minus 5. Well, heck, oh, it is x plus 5. Oh, phew. I'm going to say it's going to be messy, but it's not that messy because x plus 5 is a factor in both of them. We don't have to do anything with that. He's just already there. But there's an x minus 7 in the first one that's not in the second one. So we have to introduce it to the second one. Oh, it's going to be a Christmas one. X minus 7 over x minus 7 on that second term so that we have this common denominator. All right, so the first term, I'll just rewrite. Minus, and then the second term also has that same denominator. But the numerator is now 3 times that binomial, x minus 7. Okay, so now I can rewrite it over the common denominator. And it's 8 minus 3 times the quantity, x minus 7. And now we're at the point where we can distribute and combine like terms in the numerator. Minus 3x. And be careful with this one because we're distributing a -3. So it's -3 times x is -3x. -3 times -7. Again, a negative times a negative is a positive. So that's plus 21. All over that common denominator. So we combine terms. We have 2 constant terms, a +8 and a +21. And we have 1 x term, which is that -3x. -3x doesn't have any friends to play with, so there's no like terms. The 8 and the 21 can combine to 29. And that's it. 29 minus 3x is prime. There's no factors hidden in there. So we know that there's no common factors in the numerator and denominator. And that's it. So we know that that's in simplest form. Don't forget, friends, to type in the chat that you were here at the end, so I can give you credit for being here. And yeah, I'll be on 9:35 tomorrow for anyone who wants help with whatever. And tomorrow at 11:59 p.m. the diagnostic homework, 79 questions, friends. So get it done. Remember, in order to get to have eligibility for extra credit at the end of the semester, you have to have all your homeworks at least 20% done on time. Okay, so make sure you at least have 20% of your diagnostic homework done by midnight tomorrow. You can always go back and fix it and add more. And same goes for Friday's homework. Okay, it's also due at 11:59, and that's going to be this 7.4 and 7.5, but those only have about 12 questions each. Okie dokie. This will be posted. I'll save a copy of this filled out PDF and I'll post it next to the empty one on the lecture notes page on campus. Thanks for talking, a couple of you guys. That really helps my morale and my ability to help you.
And then we have class on Friday, right?
Yeah, same time.
Yeah.
Same
Okay.
bat time, same bat channel.
And then you want us to type our name into the chat for attendance or?
Yeah, you don't have to type your name, just say bye.
Okay.
It gives me a, transcript of the chat.
Okay, thank you.
Sure. We all good? Everyone